Venkat.
Yes, ka. Yes, yes.
நீங்க போட்றீங்களா ஸ்லைடு?
I will share, ka. No problem.
Okay. இருக்கா?
இருக்கு.
Venkat, please unmute the persons.
Yes, sir.
You can do unmute to all also. In case if the people needed to talk, then they can unmute. And
Okay, sir. Other co-host Guna, please admit everyone. Guna, I will share the slides. Right?
Samira is there?
Yes, sir.
Sir, good evening.
Samira also. Yeah, yes, sir. You just give the admit.
Yes, sir. Okay, sir.
And check the participants. Now 42. Our Iswaramurthy sir and chief guest has to come. So after reach 90, please hold them. After they come, you can give admit again.
Okay, sir.
Full screen could Venkat. Get ready for the videos also.
Hello.
Venkat.
Yes, sir. Chief guest is there, sir. Good evening, sir.
Good evening.
Sir, good evening, sir. This is Wasimalai, sir. Yes, sir.
Yeah. Are you able to hear me?
Yeah, yes, I'm hearing, sir.
Okay, good.
Okay, sir. So kindly wait for a few more minutes, sir. People are coming.
No problem. Yeah, I'm just checking because last moment should not be any issue. That's why I made it sure that it is connected actually. So good.
Okay.
Anyway, so I'll do some more work of I'll mute and then do that. No problem. Yeah.
Yes, sir. We will give you the cocos to you.
No problem. Yeah.
Venkat, give cocos to sir.
Given.
Okay. Just play the video. Thereafter, we will stop sharing and sir will share his slide. Mercy, are you able to see the slides?
Yes, sir.
Okay. Venkat, put full screen.
Yes, sir. Over, sir. I'll play the video now. You want to?
Okay, please.
Okay, sir.
Samira, please do the admit work. People are coming.
Yes, sir.
Video தெரியுதாங்கன்னு பாருங்க. Yes, Venkat.
I think now it's visible, sir.
Yes, visible.
Engage.
Yes, sir.
And நம்ம ப்ரொமோஷன் வீடியோ இருந்தா போடு 5 minutes கிடைச்சதுன்னா.
Okay, sir.
அபிலாஷ் சொல்லி போட சொன்னானே அத.
Yes, sir. Yes, sir.
ஃப்ரீயா இருந்தா போடு.
Hello.
Yes,
Solunga.
sir.
Hello, who is this?
Dr. Ashish speaking.
Solunga, madam.
Indian Teaching College, Meghalaya.
Participant, please mute your mic as well as your video.
Okay, Venkat, please stop the screen, stop sharing. Speaker will share his slide. Venkat, are you
Already I
there?
stopped. Yes, sir. Already I stopped, sir.
Okay, sir. Director, sir, can you hear me, sir? Okay, I can contact him through phone call. Samira, many people are coming inside. Kindly give the admit. Mercy, also you can do it.
Yes, sir.
Aisha is ready. Aisha,
Yes, sir, I am ready, sir.
are ready for class?
Yes, sir, I am ready.
Okay.
Excuse me, sir. Sir?
Yes, we
Excuse
are
me,
hearing.
Sir,
Solma.
participants are around 90 has reached, sir.
Okay, Hajra madam is inside. Madam,
Yes,
are you
sir.
there?
Yes, sir.
Hajra
Madam
madam.
is there, sir.
Okay, sir and everybody is there. Speaker also
Yes,
there.
sir.
You can give the admit, no problem. Until
Oh,
100.
many are waiting. Okay, sir. Okay.
You can give. And check with Chandru, the YouTube live stream is going on or
Yes,
not?
sir. Yes, sir. It's going on, sir. I have already.
Okay. Ask to Marudh Pandit to contact me through WhatsApp.
Okay, sir.
Sir, Director sir, can you hear me, sir?
சார் லைவ் ஸ்ட்ரீம் ஆயிட்டு தான் இருக்கு சார் யூடியூப்ல.
Okay, okay, thank you.
Sir, can we play that video, sir, if sir is little bit late?
No problem, you can.
Okay.
Venkat? Venkat?
Yes, sir. Yes, sir.
Now 100 has reached, so you ask them to join in the YouTube.
Yes, sir. They are
Sir,
automatically
share your
joining.
slide.
Sir.
We are ready,
Okay,
sir.
otherwise, okay.
Yes, please. Thank you, thank you. Okay.
Rani madam is there?
Yes, sir.
Okay, then you accommodate. Otherwise, you ask them to go to YouTube, everybody. Okay?
Oh,
Venkat, chief guest is in line, so please stop the video. We
Yeah.
can put it in between our talk or in the after talk. Sir, please share your slides, sir.
Venkat, all MSc students, you can.
Okay, sir. Perfect, sir. So advances in polymer technology, everything. Okay, sir. Can you hear me, sir? Director, sir?
Yeah, I could hear.
Okay, sir. Fine, sir. Dean Madam, HOD, sir. Still 3 more minutes, sir. Can we start exactly at 4 p.m.?
Yes, sir. We'll start by 4 o'clock.
Okay, madam. Aisha, get ready, and Mercy, Samira,
Okay.
please be ready and start the program exactly at 4 p.m.
Okay, sir.
The voice audible irka, sir?
Yes, it's audible.
A kind request to the participants, please switch off your mic as well as your camera so that it would not disturb our program. Thank you so much.
Mercy, you can give the instruction to the participants. You can start with that way.
Okay, sir. Instructions to the participants. All the participants are requested to mute your mic during the presentation. Participants will be allowed to unmute your mic only during the discussion session to ask your queries. Feedback form will be posted in the chat box only at the end of the session. Attendance of the participants will be monitored. These are the instructions to the participant by the committee members. Please do follow.
Venkat? Venkat?
Yes, sir. Yes, sir.
Ensure that all MSc students should go to, other than the organizing committee member, ask them to go to YouTube. And somebody
Yes,
should
sir.
be there in the YouTube also to check.
Yes, sir.
Okay.
We have YouTube representatives there, and they
You
are
have to
taking.
ensure whether everything is screened through YouTube also. Okay. Some of
Yes.
our students should be there.
Yes,
Yes,
sir.
sir.
Yes, sir. We already have a committee, former committee. Students are there and keep on informing me by WhatsApp, sir. Don't worry, sir.
Okay.
About 28 participants are watching through YouTube, sir, right now.
In YouTube.
Yes.
Okay. HOD sir and Dean Madam, can we start the program? Director sir?
Yeah, you can start.
Okay. Director sir, can we start the program, sir?
Yes, please. Yeah.
Okay. Mercy, you can start.
Good evening and welcome one and all for this session on behalf of B.S. Abdur Rahman Crescent Institute of Science and Technology, Department of Chemistry for this 14 days faculty development program on material science and nanotechnology. A good teacher is like a candle. It consumes itself to light the way for others. And here are the days to enlighten and enhance the knowledge and skills of the faculty members. Let's start the first day session, Invoking God's Presence. For this, I call upon Ms. Aisha Begum, Department of Chemistry, to recite the Kirat.
Good evening all. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Amen. Translation: I seek refuge from Allah, from Shaitan the rejected. In the name of Allah, the most beneficent, the most merciful. All praise is due to Allah, Lord of the worlds, the most beneficent, the most merciful, Master of the day of requital. You alone we worship, and you alone we beseech for help. Guide us on the straight path, the path of those upon whom you have bestowed your favor, nor of those who are going to your anger, and nor of those who are gone astray. Thank you.
Thank you, Aisha. Welcoming is a culture. To deliver the welcome address, I kindly request Professor Dr. S. Kuttirani Ma'am, Dean, School of Physical and Chemical Sciences.
Respected chief guest and resource person of today's program, respected HOD chemistry, the coordinator of FDP, my dear colleagues and learned participants from various colleges and institutions. Very good evening to one and all present here. I am Dr. Kuttirani, Dean for the School of Physical and Chemical Sciences from B.S. Abdur Crescent Institute of Science and Technology, Chennai. It gives me immense pleasure to welcome you all for the inauguration of 14 days e-faculty development program on material science and nanotechnology organized by Chemistry Department of BSA Crescent Institute of Science and Technology for 14 days from 3rd August to 17th August 2020. First of all, I welcome our respected chief guest and resource person of today, that is first day of this faculty development program, Dr.K.Rajkumar, Director, Indian Rubber Manufacturers Research Association, Ministry of Commerce and Industry, Maharashtra. He is kind enough to accept our invitation and being here even during this pandemic condition. I welcome you, sir. I am happy to welcome Dr. Ishwaramurthy, HOD Chemistry, BSA Crescent Institute, for his support and encouragement. I take this opportunity to appreciate the efforts taken by our faculty, Dr. Vasimalai, who is also the coordinator of this event, for organizing this faculty development program and identifying the resource persons from various central institutions for all the 14 days. I extend my warm welcome to all the participants. Research in the area of material science and nanotechnology has been growing, and it has been improvised for the past few years. In this program, the latest fundamentals and applied research advances in the field of material science and nanotechnology are going to be discussed in detail. I sincerely hope that the deliberations of this FDP will widen the horizons in the respective field. At this juncture, I would like to mention that we have received tremendous response from many participants from various institutions and colleges all over India. Now, almost all the institutions and colleges have started offering education through the online mode. So, in order to enable the faculty members to take part in this FDP without disturbing their routine work, we are organizing this FDP during the evening time. I believe that all the participants will have resourceful experience in all these 14 days. With these few words, I once again welcome you all. Thank you.
Thank you, ma'am, for such a warm welcome. Next, I request Professor Dr. Ishwaramurthy, head of the department, to discuss few words about the program.
Respected chief guest of today's event, Dr. Rajkumar, Director, Indian Rubber Manufacturers Research Association, and respected Dean, School of Physical and Chemical Sciences, and my dear colleagues and the participants. I, Dr. Ishwaramurthy, Head of the Department of Chemistry of B.S. Abdur Rahman University, has immense pleasure in giving the presidential address. Actually, the Department of Chemistry is frequently arranging webinars, workshops, and other events, but this is the first time we are conducting faculty development program for 14 days in the history of Crescent Institute of Science and Technology. And as already I welcome all the participants on behalf of the Department of Chemistry, and we have chosen the speakers from different regions of India, north side, western side, eastern side, and the participants also representing all over India. And the topic chosen also not only nanotechnology in the various domains of nanotechnology, especially the nanotechnology in agriculture, nanotechnology in medicine, nanotechnology in sensor, nanotechnology in catalysis, nanotechnology in photocatalysis, etc. And to enable the faculty members to participate effectively in this program, we have arranged the program after that 4 o'clock to 5 o'clock only. And most of the resource persons are highly expertise in their field, and all of them are having that professor, director, or HOD rank. They have been experience of more than 20 years, and hope you will be enlightened on the materials and nanotechnology, on various aspects of nanotechnology. And as you know very well, that material science and nanotechnology is an hot topic nowadays, and most of the research papers are concentrating on the nanomaterial only for varied applications. So hopefully you will be enlightened by the speakers, because they are representing from IITs, NITs, and central institutes. If you have any doubt, you can clarify the doubt with the speakers. I hope you will be enlightened by this lecture. All the best for your 14 days program. Thank you.
Thank you, sir. We hope this session will be more enlightening. Now, I kindly request Dr. N. Vasimale, Assistant Professor Selection Grade, and also the coordinator of this faculty development program on material science and nanotechnology, to give a brief introduction about the speaker, Dr. K.Rajkumar, sir, Director, Indian Rubber Manufacturer Research Association, Ministry of Commerce and Industry, Maharashtra.
Okay. It is my immense pleasure. Can you hear me, Mercy?
Yes, sir, I can hear you.
Okay. It is my immense pleasure to welcome you all again to this 14 days FDP on material science and nanotechnology. Respected Chief Guest, Dr. K.Rajkumar, Director, IRMRA. Respected our School Dean, Dr. S. Kutirani, School of Physical Chemical Sciences. Respected our HOD, Dr. D. Ishwaramurthy, Department of Chemistry. And dear participants, good afternoon to all. You know, well, the 14 days program, we found a very good speaker. All the eminent speakers are leading scientists from IIT, NITs, ISER, Central Universities, and Central Funded Research Institute. I agree with Ishwaramurthy, sir. Whatever he said, everything is correct. And moreover, I want to say one more thing. I have covered the speaker from all the corners of India. For example, one speaker I found in North Punjab, so Vijay Kumar, and two more I found from the south, Kerala and Tamil Nadu, and the east, West Bengal, Kolkata, I found some speaker. So west side, Maharashtra, of course, today our chief guest is from Maharashtra. So I found some people from all the corner of India, and definitely this FTP will be useful for all the participants. Before I introduce the chief guest, I thank our today chief guest, Dr. K.Rajkumar, Director, IRMRA, for his kind acceptance of our invitation. So director's profile is lengthy one, but I'm going to list it in a short way. Director has been finished his MSc Chemical Science and MTech Rubber Technology in IIT Kharagpur and PhD Polymer Nanocomposite and MBA. Now he is working as a director of IRMRA. It comes under the category of Ministry of Commerce and Industry, Government of India. special role. Director is a chairman of a BIS PCD 29 and member of several bodies, including BIS PCD 13, ISO TC 45, etc. And he has more than 22 years experience. Sir has published more than 50 publications in high impact factor journal, international journals, and published in several book chapters also. Director field of specialization has been focused on the rubber compounds development and cost reductions, rubber production developments, and failure in investigations of rubber productions, test methods development, polymer nanocomposites, involving in the different defense and nuclear sector project, etc. SAR has guided more than 50 UG students and more than 20 PG students for their industrial projects. And SAR has received several awards, including Bharat Seva Ratna Gold Medal Award from GEPRA and ISO 45 long service award from the International Standardization, and received the Nuclear Recycle Board Award from the Indonesians of Rougher Content, and IRMRA Memorious Cash Award SAR has received for the polymer gauntlets, and several awards received NAIP awards in the year 2012 for the successful execution of rubber tame projects. And SAR received in Tokyo, Japan award as a IRMA seminar. He went and attended that IRMA seminar in Tokyo, Japan also. And affiliations, now is a chairman of BAS PCD 29 and member committee in several bodies, as well as government council member of rubber skill development and member of various bodies, AIRMRA, IRI, ASM, and international bodies, and vice president of Quality Forum. And SAR has visited several countries. The list is big. I can tell a few things. States, Germany, France, Italy, Japan, Belgium, Netherlands, China, Thailand, Malaysia, Vietnam, South Africa, and Indonesia, etc. So fortunately, we had a chance to bring such an eminent person as a chief guest today. So on behalf of Department of Chemistry, BS Abdur Rahman, Crescent Institute of Science and Technology, on behalf of our participants, I welcome you again, sir. Thank you.
Thank you, sir. Now we request Dr. K. Rajkumar, sir, speaker of today's session, to take over the presentation.
Thank you. Respected Dean Dr. Kuchirani of BSc IST Chennai, Head of the Department Professor Iswaramurthy, Dr. Vashimalai, the coordinator of this 14-day faculty development program on material science and nanotechnology 2020. It is organized by BSc IST Chennai from 3rd August to 17th August, sorry. And this 14 days program. And it gives me a great pleasure to be part of this event as a chief guest and inaugural speaker of this particular 14-day FDP. And I thank the organizer for this wonderful opportunity to share my experience, especially in front of August gathering of eminent faculties and the academicians, researchers gathered in this particular FDP. And it gives me great pleasure to share the experience on this particular forum. As said that, like, basically we have been, the country and the world is undergoing a serious pandemic situation, wherein that basically everybody is under lockdown. And this is a wonderful initiative by Crescent University to gather such a huge gathering for developing the competitiveness of the educational institutions under auspicious program of faculty development program. And program definitely having gathering of eminent speakers from different institutions and across the country gives really a pleasure of sharing such experience, and it will develop the skills of the faculties who are nurturing the youngsters and who will be teaching the students in future basically. So I have taken the topic as a part of my professional advances in polymer technology and nanocomposites, and especially to highlight some of the emerging fields of research and highlight the need for the future research so that the faculties can take over to the next generation of students and they can develop, they can do the, develop the students in this particular research basically. So, excuse me, slide is not moving. Yes. So as a part of a faculty development program, I thought that as every student has to undergo a competency development apart from the qualifications. So the training and skills are the part and parcel of the the competency, and experience is acquired over the period of the industry when they get into the job basically. When you see that the opportunity comes only when they are adequately qualified and skilled enough to get employed. The role of faculty is to create employable human resource and also nurture the research aptitude. So it is very important to nurture the research aptitude when they are in student, and hence this faculty development program will make lots of opportunities and opening for every faculty to grasp some areas of emerging areas of research needs for the future basically. So what the industry needs will be known, and what is the area of research will be known through this FDP, and hence the faculties will get a sense of the future direction of the faculty teaching program future, so that the students are focused on that particular area, and hence the career in rubber and polymer industry also will be a part and parcel of this faculty and development program, because I am from a rubber industry background and polymer is part and parcel of the chemistry and rubber is a part of polymer, and hence I would like to highlight the industry about rubber industry, that over 50 lakhs of manpower is employed in rubber industry, and hence more opportunity is waiting for. So if you look at this, the tire industry is having more than 60,000 crores, 60,000 crores of turnover, and non-tire, that is other than tire, 30,000 crores of the turnover, wherein that huge employment opportunities are awaiting basically, and hence the faculties from the chemistry department can very well nurture the students to get into the research oriented towards polymers and also get into the rubber and allied industries. There are ample of opportunities available. just for the given a chance that just look at this figure, this picture, where the tire industry is very well grown, is growing, the export is growing up compared to the import. Export is very well is so industry is exporting. The tire industry from India is exporting a lot to the world market, global market, and hence very well. They also look for lot of manpower for future needs actually. Whereas when you come to the non-tire part, the import is more than the export. That means there is an opportunity for us to, indigenization, that is make in India, so that the industry can do better in non-tire sectors basically. So keeping that in mind, IRMRA, where I am from, basically, I'm leading these particular institutions. We also conduct lots of training, workshops, seminar, conference, academic programs to upgrade the skills and requirement of, excuse me. And hence, there is a need for online course and upgrading training programs. With lots of demand, IRMRA is organizing 1-year training course on certificate course on rubber materials and science and technology. The application call for is already there basically. And to that effect, IRMRA is basically is getting upgraded to the renaming of its parent name from Indian Rubber Manufacturers Research Association into Indian Rubber Materials Research Institute. Basically, the manufacturers and association words are misleading the industry, and hence the Governing Council and Government of India has given the consent for changing its name from association into institutes. And hence, more suitably, IRMRA is getting into the educational affairs of developing competent manpower for the rubber industry. Now, when you come to the polymer advancement in polymer technologies, I could divide into 4 areas. The main is that polymers and modifications, which is advancement, wherein that the recyclable and biosource based polymers are being attracted today. And we'll talk this little more about later. The second one is additives and chemicals, wherein that the polymeric chemicals, associated chemicals, especially the REACH and ROHS compliant, lots of the materials are restricted, especially on the ground of REACH and ROHS. So the industry is under pressure to find an alternate resource, alternate chemicals for additives and all basically. The third one is the fillers technology. The fillers technology in the sense, of course, the nanotechnology, the bio-based fillers. Basically, the carbon black technology is already there in rubber industry, but there is alternate resourceful technological based fillers is being explored for the industry, rubber polymer industry. The fourth one is energy efficient process technology, including the industry 4.0 and all basically. Now, biofiller is a future, which is also part and parcel of the emerging research as a part of filler and technology, apart from the nanotechnology. Basically. When you come to the rubber industry or polymer plastic industry or polymer industry, the circular economy is the most emerging field of research, basically. So that means that every industry is working on a materials, it's environment-friendly material technology, obviously energy efficient processes, and part and parcel of circular economy, which is waste tire recycle management basically. Now if you see, for example, the rubber tires, the consumption of rubber in the tire area basically, the tire waste tire management is a huge problem basically in the country, including the world, of course. So the circular economy is giving a word in the world directions that basically how material technologies should look into it. For example, The linear economy, earlier when we say that the raw materials are procured, productions are done and used, the remaining part is simply wasted, dumped into the industry or environment. Least bothered about is secondary use, tertiary use basically. The later on, economy with the feedback loops basically, raw materials come in, productions and use, recycling, and some of the waste has been converted into the usage and so on basically. The today's circular economy is that basically it is the most utilization of the resource within the circle basically. That means basically, for example, if you given a tire, if for example, the tire has got lots of materials inside. On the surface, it might get worn out basically. Whereas the interior, the carcass and other portion, rubber materials have highly calorific, value-based natural resource of petrochemicals. But now the industry is looking forward a technology where we can utilize efficiently such resources instead of getting into the landfill and dumping into the ground or environment. Considerable research has been done on energy efficient processes, including the crumb rubbers and reclaim rubbers, etc. The only point is basically there has been lots of concern for the environmental issues while doing the recycling or the converting into the new materials. So the chemistry is involved here is incineration or some chemical treatment or mechanical treatment with some chemistry. So here lots of environmental issues are coming up. So there is a requirement for doing research, environment friendly research, converting this waste tire rubber into a useful materials which can be used in tire industry or even other rubber or polymer industries basically. So there has been considerable sustainable technological solutions have been addressed. We are also part of the research we are doing with the collaborative research with Anna University Trichy and other institutions also. Our own scientists are doing research. If you look at it, it's a little bit old data, but of course that the trend still continues basically. From 1992 to 2005-6, there is landfill has been reduced and the recycling is being increased basically. So there is an increase in the recycling trend, which is value-added product is created from this waste basically. The only thing is that furthermore to add the values on this, how we can make much more useful into the system so that we can minimize the resource which is drawn out from the nature and utilize this particular recycle into the circular economy so that the future is always brightened basically. The most important is we need to conserve the resources available in the nature basically. So natural rubber is main resource in tire industry and there is a scarcity of natural rubber and we are importing from other countries. If this is going to be a part and parcel of the research program in future, utilizing the recycled materials as a part and parcel of the resource useful for any production is going to be the mandated in near future. That means that one must have accountability to reuse within the system before it gets into the environment or landfill or any environment thing basically. So that is why the bioadditives, second alternative is the bioadditives, which are alternate additive substitute for petrochemical based materials, especially most of the chemicals which are used including the carbon black from the petroleum based basically. So anything petroleum based is costly and it is environmentally is not friendly, and hence there are possible alternatives, options are being explored as a sustainable technology solutions. So we are doing research and collaborative research with IIT Kharagpur and other institutions on this particular area also basically. So here biomass is considered as a good candidate for renewable resource, and biorefinery is just like a petroleum refinery. Only the source of energy is the biomass, and hence IRMRA decided to work on various bio-based additives as an alternate additive development for polymer and rubber industry, which we have been working for last 10 years, and we are also involved in patenting basically. The third one is energy saving potential basically. There is enormous potential opportunity to save in industries, and the polymer comes from the petrochemical industries. So about 10 to 25%, it is possibility is there in the sectors. So cost per productions, any kind, wherever you are in whichever product it is, how to reduce the cost of energy based things, energy saving potential to be tapped and explored as a part and parcel of basically. So the most important is today people are talking about industry 4.0. This is another, the process based research where the process intensifications, energy efficient and environmental friendly, all such things basically. So here, the role of faculty is to create employable human resource, not only that, to shoot for the industry 4.0. When you talk about industry 4.0, it is not a simple chemistry, it is not simple any engineering degree. So there is a need for them to know many other things basically. So that means it is an interdisciplinary program. So the computer, electronics, electrical, mechanical, and of course the core chemistry, all are involved in this particular area basically. So the role of faculty is here to nurture the research aptitude for industrial needs, that is interdisciplinary research, to address a smart factory. The smart factory in the sense basically it is going into the digitizations, Internet of Things, and manufacturing technology is coming into the next level of automations basically. So wherein that basically everything is sensed by the so-called computer simulations, etc. So there is an enormous need of interdisciplinary research. So just by having a core branch expertise alone will not be sufficient for employable in the nature basically. So it will be very important. So having done all such things basically, the polymer composites is another area where emerging technology, which is the filler-based, material-based research is taken place basically. So in such case, basically, a lot more research have been done even in the polymer nanocomposites. Here, the matrix with the different polymeric matrix with the blends or single or tri-blends, having materials of nanomaterials dispersed in the space is being addressed over here to fulfill the synergetic application of two or more materials. For example, let's say that like you have a polar material, a non-polar material, which are coming together with a compatibilizer, the blends of materials, having individual characteristic of polar and non-polar, addressing to the solutions of single material solving both the problems. Obviously, one has to be a very balanced in the particular materials blending and all that is being addressed basically. So the important features of this polymer nano or polymer composites are basically lightweight with a higher strength and the improvement of properties like thermal, mechanical, electrical properties, including the highly corrosion resistance. Many end applications, presence of interface makes a lot more things basically. So when you talk about the polymer matrix, basically composites, you have thermoset, thermoplastic, rubber, which is of course known. One has to look into this difference. Basically, rubber is natural rubber or synthetic rubber, or even a blend of natural and synthetic rubbers. Wherein the carbon black and silica, other inert fillers like clay, silica and calcium carbonate, titanium dioxide, many zinc oxide, all such materials are added as a part and parcel of the fillers. And today there is an advancement over the carbon black because carbon black is considered to be a nanoparticle. In the past, basically, it was a part and parcel of the rubber technology. It was understood that when you reduce the size from particulate fillers to the coarse fillers and come to the reduce the filler size, and it increases the surface area and activity and so on. Basically, of course, I'll explain. There is on another slide how it is reinforcement is increasing. And that respect, basically, advancement was there, basically. Over and above, now nanotechnology has taken over a little more. And similarly, the thermoplastic is, of course, is a part of polymer, wherein lot more, is thermoplastic. Mainly, it is recyclable, addressing the thing, basically. That is very important. And plastic industry as a whole is a huge thing, basically, which I generally don't get into that, because more of rubber and polymers related to that only I generally take, because it's a huge subject, basically, as such. Thermoset, again, like resins, polyester resins, epoxy resins, fiber reinforced, GRP, or glass reinforced, or fiber response, they are all there as part and parcel of the thing, basically. So they're mainly the thermoset. Now, the thing is that here, of course, if somebody can make a recyclable, reusable, that is more important. Now, again, the decomposition and biodegradability is the most important. So the plastic industry also is getting into the how during the work it should not degrade, but once you dump it in the ground of environment, it should be so-called biodegradable, and it's a mystery, basically. Everybody wants a typical characteristic. As long as in use, it should not degrade. Once it is dumped, it should be degrading faster, basically. So this is a typical requirement, and so especially the packaging industries and all, like several area where this kind of problems that is, basically. And as a carbon metal matrix point, basically there are a lot of aluminum, titanium, magnesium. So there is another metal complex composites, basically. Then ceramics, which of course again is a bit of different one, wherein that like another nanotechnology is big debate is going on, basically. Recently, there has been an invention of new material called Proteus. Is reportedly the world's first uncuttable materials. It is having only 15% of the density of steel. If you just get into the Google, you'll find that Proteus is, you'll find that it's the world's first uncuttable materials, and it is reported as very light compared to the steel, and is the thing. So in future, most of these cutting tools and many applications, this is likely to be there as a part of it. As a material technologist, it's important for things, basically. Now, when you see that the carbon black, I was telling that basically a carbon black, which is also a part and parcel of nanotechnology series. Only thing is that it is just touched upon certain nanometer, but not further down. But when you see the particle size, when you broken down is of materials, the surface area is increasing. That's what the figure says, basically. How and the particle shape and surface activity all matters, basically. So how the primary particle size, its distribution, the surface roughness and porosity, structure, irregularity of the aggregates, geometrical factor, aggregate and shape, anisometry, bulkiness, aggregate size and distributions. So these are the carbon black factor, basically, and that were limiting the technological advancement in the carbon black. Now the surface chemistry, surface activity takes over, especially in the nanotechnologies, much more on this particular front of area of research. So in a tire compound, for example, lots of advancement has taken place. Wet traction and then the rolling resistance, skid resistance. So these are some of the areas tremendous improvement has been found with the advancement in the filler technology. Especially they play with the structure and surface area of carbon black, and they found a tremendous improvement. Even with the silica, nanosilica, and nanofillers got advantages, basically. So polymer nanocomposites, again, when you talk about, on the basis of dimensions, at least one dimension should be in a nanometer, and it could be one dimensional or two dimensional or three dimensional, and the fillers having dimension in nanoscale, exceptionally high surface to volume ratio, will give you a reinforcement phase, and it's exceptionally high aspect ratio, and the reinforcement is mainly based on its interaction with the surface activity and because of the high surface area. And here the point is the very small doping, or you can call it dose, it gives excellent reinforcement basically. Now The most important here is the dispersion, interfacial, dispersion, state of dispersion, interfacial interaction with the, the polymer and the rubber and filler, area of interface between the matrix and reinforcement, improved compatibility with the matrix. So the compatibility comes with the, the different matrix and polarity and all basically. So the distribution, uniform distribution, dispersion is the most important. So if it is very well absorbed in the rubber chains and uniformly distributed, the rubber, the strength becomes better instead of filler aggregates like left hand side. The aggregated particles, the interaction with the polymer will be very less, whereas when it is dispersed very well and the surface area is exposed to the entire rubber molecules, molecular level polymers gets interaction and the strength will be much better. When you come to the nanocomposites, there are several nanomaterials are used in polymers, especially carbon black, which is of course 20 to 250 nanometer, which was earlier also used, and graphite was also part of the basically. And carbon nanotubes, CNT, POS, and the LDH, nano zinc oxide, nano calcium carbonate, magnesium hydroxides, nanosilica, modified nanosilica, then silicates, clay. So IRMRA is engaged in collaboration with almost all of these materials, and collaboration research work is going on with the VNIT, IIT, and other leading universities. We welcome more collaborations with IRMRA. Any of your faculties are interested, they can write to us with the credentials. What I meant to say, basically, there are a lot more opportunities can be explored on this area because the laboratory level, lots of trials have been done and published. Thousands of papers are available in the, things. But the only important is that the commercialized technology is still yet to explore, basically. The reason is basically that when it goes to the higher level of scale, the material gets agglomerated and dispersion becomes problem. So the conventional mixing tools of the Banbury or mixer or any kind of the normal material, normal mixing process equipments are not so explored, not so useful basically. So the materials gets agglomerated and is not giving the real sense of thing basically. The second one is basically here is the cost of incorporation in a process or in the product. So the cost per unit is going up very high basically. For example, if it is a 200 rupees a kilo of rubber of compound basically, and you add a 0.1, 0.2 pH also, it goes up by 200 becomes 400 rupees. So it's not affordable in terms of the affordability in the industry basically, even in the unit cost of the product. So there is a lot more research to do, without compromising the properties, without compromising on the processing ability, and low cost filler is, so if there is an opportunity to reduce the cost of manufacture and bulk manufacturers and then get into the industrialization, commercialization, so there is a huge welcome for the industry. So the advantage is basically there are several advantages over the polymeric nanocomposites, mechanical properties, strength, modulus, dimension stability, and all like this is quite good. Decreased permeability to gases, water and hydrocarbons, thermal stability and heat distortion, flame retardancy, of course, chemical resistance improves, surface appearance improves, smoothness, shining, everything is perfect. Electrical conductivity is good. Optical clarity in comparison with the normal conventional fillers is quite different basically if you say that basically. So these are some of the benefits basically. Similarly, electrical conductivity is increased. So we can say that anti-static properties are improved, improvement of mechanical properties, enhancement of thermal stability, enhancement of thermal conductivity, fire retardancy, oxidation stability. So these are the highly advantages. The only question is basically how to stabilize and how to make it into the production level, commercial level basically is the problem, because everything works fine in a laboratory scale, small, 500 gram, 1 kilo, just do it and then do mold and then do the testing and then you're able to get excellent result of all such things. When you go to the 30 kg or 100 kg or 200 kg bulk productions basically, so there is a huge problem, the processability problems. So there is maybe machinery related research is needed, and fixation of morphology, all such things are basically. So the disadvantage of nano-sized addition is only thing is that with agglomerations, the toughness and the impact performance. So there is understanding the particle size reduction and surface area improvement and shape, optimizing the shape, surface area, all those things is good, fine. But the only problem is the agglomeration makes it the problem basically. So this also gives good barrier properties, high aspect ratio, mechanical reinforcement, high retardance, all this rheological control, everything is perfect. There's no problem. So while incorporation of nanofillers, especially with a very, very less minor quantity, we found that to enhance several properties, including barrier properties and thermal resistant properties. But the problem is dispersion of such nanofillers and polymeric matter is a big challenge and to the polymer technologies. So we also have done several attempts, including trying to disperse in different rubbers with different applications, basically. And there are the various methods which are known and is published in the industry and journals. You can see that melting intercalations, in situ polymerization, solution polymerization, intercalation, plasticization method. So these are all the conventional methods, preparation for the laboratory level. But when you go to the industrial commercialization level, these things are not being commercialized. That's a problem they are facing basically at their level. Maybe if it is solutions, it is environmental problem. If it is in situ, the reactor is not sufficient because it's everybody cannot have reaction, reactors basically. So they can do it, but they are also facing some other process problems. Melt intercalations, yes, of course they do it, but again the conventional machine cannot be useful basically. The plasticization method, of course, is also it has got its own limitation. So every method has got its own the limitations wherein that basically. So have we done that? What is this intercalation and the exfoliations? If you see the pictures, basically intercalation means the polymeric chains are getting inside the the layered material. So the nanocomposites basically. So the creation of such fixation of morphology between these two layers of nanocomposites, fixing these things basically is important. It has to stay back inside, and the coiling, uncoiling will take place during the when you do stretch and then do that when you mix and then. So different the molecular level problems they face. Basically the same thing with the exfoliation also. So in this case, basically materials, the polymeric chains get inside the things and distributed among these particular nano layers basically. But the strength is of course is quite different when it is coming to the materials composition and analysis basically. So after that, when you see when you try to fix it during the mixing or operations, it is quite okay. But after some time, what happened? De-agglomerate dispersion. So basically, it comes into a different problem basically. So when you examine through the TEM and other things, we found that there is different pictures basically wherein that like this distribution and dispersion of these nanomaterials inside the matrix is quite different in terms of So the in situ polymerization has got advantage and disadvantage. Melt polymerization, melt mixing is again with different things basically. So starting from a master batch, highly concentrated master batch is another area where that like basically you take 1 kg of let's say natural rubber or SBR and mix some the CNT and then make a concentrated maybe 20%, 15%. And then when you mix a normal one, so take some 10 parts of this, will have 1%. So that will be added into 1 kg and then so it becomes 0.1 kg and then mix and then do it. So what happens basically, the concentrated polymer is carrying the materials inside. So probably that the dispersion is okay when we do it at a lower level. Again, when you go to the higher level of big size match, basically, so the distribution is not so good. Maybe the dispersion is good in a smaller batch, but distribution is not happening in the larger level basically, because that within the residential period of 10 minutes or 20 minutes of original mixing, it's not happening basically. So this is really a challenge which for mixing of such things basically. So, and direct incorporations, again same thing that basically here, the surface chemistry and interfacial tension, all such, the chemistry plays a major role. So the main important, the solubility parameter and, then the polarity also match that. So what, thing is basically, the researches are being done is basically purified monomer initiator they put together as a part of during the in situ of polymerization. Modified nanoclay itself is made. So the modified nanoclay means it is organo-modified. Basically, it is a part and parcel. It means some kind of organic coating is done on that basically, and then it is added there actually. So then comes to the polymerization, and then so what really happens basically during the polymerization from the monomer, this material gets incorporated and then bring basically. So this is how one part of work basically. So then remaining all like drying, molding, and all such things the same basically. So this is how in situ polymerization. One is basically rubber is taken and the solvent, then they make the solutions, and then put the nanomaterials into like basically, for example, the same solvent used for clay or any nanomaterials, and then use. And now the solution of the nanomaterial plus rubber solution is mixed and then created, and then get into a drying and then casting it and then make it. So this all is practically possible in a lab scale, but it's not possible in the thing because so much of solvent will be escaped. So what really found in the academic research is basically using the solvent, you are able to incorporate nanomaterials into the polymeric matrix. Wow, wonderful. Okay. But when it goes to the industry commercialization, people really feel, because IRMRA institutes basically we closely interact with the industry and they look for a technology which can be implementable. And so one part is the technically feasibility. Second is commercially viability. So what is feasible and technically is not commercially viable. What is commercially viable, not technically feasible. So these are the complex situation is faced in the industry. So there is a lot more research needs to be done, mainly the academic industry collaborations. So this kind of platform where industry, the faculty should learn what is need for the industry. That should be the focus for the research, so that then the students are exposed to the problems of the industry right now, right away, and they are getting ready to face in the future. Otherwise, when they get outside the industry, then they found nothing is what is learned is something is not applicable here and it's not happening. So then they get frustrated and they are not able to perform in the industry actually. So there is a need for such things. Similarly, this is a part of my research, of course, a PhD, wherein that like the liquid plasticizer or the liquid rubber is taken and nanofillers are mixed over there, and then that dispersion used as a part and parcel of carrier for them. For example, liquid NPR is taken, or DOP or DAS, or even the aromatic oil, or, for a compatible oil, whichever there. If it is a natural rubber aromatic oil, if it is SBR, naphthenic or paraffinic, basically VPDM, naphthenic, paraffinic. So depending upon the compatibility, take that material and dissolve, rather just make a paste of or something. So what happens? The nanofillers are made to disperse in this liquid. So the liquid carries better in solid dispersions, basically. So that is one of the advantages we try to use it. Of course, it was quite good in dispersants, but again, the commercially it is not very much appreciated because the volume of what we are looking forward is not that much compared to the thing. So maybe the other methods like taking the rubber master batch, then again this kind of process could be another. So there is more to do the research basically. Next is basically nanomaterials as a fillers, different reinforcement mechanism and plus barriers. So what are the advantages? Basically high resistance at high temperature, low bottleness. The only the higher durability, reduced weight, reduced rolling resistance, and all like basically. So these are the advantage of having these nanomaterials. So when you talk about organic clay or carbon black and silica, so when you compare basically, so the aspect ratio and the particle size is basically so. See, when carbon black and silica is much larger in diameter, 10 to 70 nanometers. When it comes to organoclay is 100 to 1000 nanometers. Here basically the thickness is 1 nanometer. So the layer, silicate layer is basically, so here the spherical and it is a layer, and surface area is more than 300 on exfoliations, whereas here 30 to 200 basically. So aspect ratio is lateral dimension divided by thickness, basically 50, whereas here it is 1 to 3. What is basically when, if you are able to control the structure of these materials, even more the surface area and becoming more on exfoliation. And so what really happened, the interactive surface available for interaction with the polymer on the surface of the filler is much more compared to a spherical one here, and because of agglomeration and this thing basically. So this is the narration basically, which of course there are a lot of things. So we tried to do some research on this, some of this thing basically, same like nitrile rubber, HNPR, wherein that basically, nanoclay we used to do 0, 3 and 5 parts, 7 parts. And you say that nanosilica 0, 1, 3 and 5 parts with the same, we have taken the BCP as a mechanism for curing. And we try to do research. Basically here is, the strength is improving with the things basically. And same time, nanograpphite also we try to do that. Basically the thermal stability is increasing, mechanical strength is improving, and barrier properties are reducing basically. So all such things we have done, these things basically, including, the tear resistance improving, mechanical properties are improving basically. Thermal stability, when we do that TG analysis, the PHR, it is, thermal stability is increasing. That shows basically, it's all even in, the laboratory level, it is proved basically, but only when it goes to the higher level, of course, the materials characteristic will not change. Only the fixing the morphology on that is the most important. Similarly, graphite sheet as a molecule for interlocking hexagonals is more important. All those, the orbital of these extra electrons overlap. So these are the theories of graphite theory, wherein that basically, they can be used as a part and partial of reinforcement basically. So in all these respects, basically, these are the areas, emerging areas. Basically, if you try to use whichever the method, whether it is of casting method or for example, solution method and this thing. So you try to do that and get into the materials properties and do the analysis. The main point is usable in the academics level, but not in the industry level. Silica is reinforcing filler for elastomer. Again, here it is used as, silicon rubber is used as siloxanes are available there for interaction. So silica is a mechanism for improving silica as a filler here. And now today the industry is, using silica as a part of replacement for carbon black. The latest technology for the, decreasing the rolling resistance, greenhouse emissions, mainly because the moment you reduce the carbon black, you are winning the carbon credits here basically. Now what happens basically, in order to prepare 1 ton of carbon black, equivalent 1 ton of carbon dioxide you are emitting. That means if you are using 5 parts, 10 parts, replacing the carbon black by silica or any alternate materials, you are equivalent amount of carbon dioxide or emissions you are saving in the environment. So it leads to a, environmental savings and other things basically. So decrease, that is a trend now. Actually improves thermal conductivity and all this. So silica as part of useful for the elastomers, especially natural SBR blend. Tire industry, they are trying to use this techniques basically. And of course, the surface treatment of silica is play a very major role in doing that basically. So all these things basically, what is happening is the drawback is the aggregation of particles into rubber matrix, which I was telling, wherein the strong filler-filler interaction, incompatibility with the rubber matrix, cure retardance effect. Especially because these fillers used to be acidic in nature, whereas these curatives are usually basic in nature, and hence what happens, they start reacting, the curatives start reacting with this material, and hence the retardancy takes place. That means the curing will not take place on time. So you may have to give more time for that basically. So difficult in mixing and processability with this low particle size rather nanoparticles. So these are some of the drawbacks during this materials basically. So here, for example, when you do some modifications of fixing the silica, for example, MPS and APS is used as a 10 pH, and So the distribution dispersion becomes very good in terms of um, morphology fixation. So the modification, siloxane with modifications basically leads to a better dispersion. So these are some of the chemistry surface modifications, and people can take basically, so especially more and more research needs to be done, which is just modifying the surface. Because nowadays, of course, organosilicon modifications are there, but now if you add something more like this, so the conventional fillers, normal matrix, but with some modifications. There is an increase in the strength and properties, leads to a huge benefit in terms of the properties basically. So when you say here, for example, there is an improvement of mechanical strength, and also the modulus properties are increasing with the modifications of the surface. I mean, that is mainly because of the better compatibility and fixation of morphology in the application. So it's a huge benefits in nanocomposites, especially in applications wherein that automotive application, of course, the huge it is basically engine cover, and because nowadays most of the nanocomposites are happening in polymers, useful in with so especially even in the aircraft, where lightweight materials. So when you are reducing the weight by a certain percentage, the mileage and the fuel consumption is less, and improvement in the performance and toughness and longevity is durability is increasing. All such things are being addressed basically. So similarly, engineering applications, lot of applications here, aerospace, automobiles, and constructions, several areas where these kind of opportunities are there, and they have been worked on that basically. So with all these things, we try to see that there are lots of research are being done, and we have been working on this basically. So it's not only IRMRA's publication. IRMRA is with a collaboration with institutes like NIT, IIT, or even the BARC. So we have a long association with the different institutions, especially to develop the needs of the industry. So these are some of the references of various publications, especially on the natural, nanocomposites. Now, of course, there are other, publications, but I listed especially on these particular publications. Of course, I did not highlight more depth of technicalities of each, because they're huge. Of course, I try to only highlight the, the advancements happening in the industry and difficulties faced with it, so that the faculties can catch up some of these points. Of course, anything you want more interactions, you can always come to us and interact with us and create some valuable research field wherein that you can work for the growth of the rubber industry. So we always believe in new technology partners with the pay, royalty, TOT, no shortcuts in technology acquisition and killing the business opportunities. It's always, we respect the hard work, but also be smart, so that's what I would like to say. With this thing, I would like to thank the organizer for giving me this wonderful opportunity. I'm sure that basically, I try to highlight some of this advancement in the polymer technology and the advancement in technology wherein the industry is looking forward, expertise and research areas basically, and more to do. Lot more things can be done. Of course, the only thing is that if you find any problem which is useful for the industrial application, solving either environment problem or process problem or energy conservation or the commercial or the cost reductions, that will be more welcome to the industry. I'm sure that basically we all tuned to do so. So the faculty should concentrate more into such research, because when you do so, the students will get tuned into that and they will be welcomed by the industry. Because otherwise, when the student goes to the industry and they are getting into a more of academic thing basically, and they are not able to sustain. So, or they need a more time for them to, in case that means 1 year or 2 years, they only spend as a trainee, then they learn, they have to unlearn what they learned in the academics and they're doing. So only you are giving the learning capability, but rather than, so what we need is basically they need to be given with more technological, commercial, and also research attitude to shoot for the industry. So that is the upcoming skills basically. So if there is a need for any change in the syllabus, I think it is essential to discuss with the industry, academic, and the research institutes like IRMRA, or other similar organizations, so that the syllabus is oriented towards the needs, and hence that the needs of the industry is addressed, spoken in the classes, and they are given the practicals. They are able to solve it basically. So with this, I would like to end my presentation, and thank you very much once again. Over to the organizer basically.
Thank you, sir, for giving us such a deep knowledge in advancement in polymer industry, waste type disposable management, bioadditives, etc. And also stressing the importance on the role of faculties to create employable human resource and nurture research aptitude. Thank you once again, sir. Now the session is open to all the participants to ask their queries. You can unmute your mic to ask your questions. Participants can unmute your mic to ask your queries.
Okay, Mercy. If no question from the participants, you can read the chatting box questions from YouTube.
I have one question, please.
Yes, sir. You can. Yes, please.
Okay. My question is that when composites are prepared using solution polymerization process, I think some solvent must be trapped inside the polymer matrix.
Yes.
And that may cause some properties, decrease in properties. How do you overcome this drawback?
So basically, that's the problem with this method as such. I have been telling basically, if it is a thin layer of casting, the solvent gets evaporated and it's good basically. Whereas if it is a thick articles, if you are producing a little more thicker also, then there is a possibility of solvent. So you need to see that the drying temperature, optimizing the drying temperature, and ensure that basically a constant weighing is there basically. So these are the methods. So it depends upon what temperature you are doing, what solvent is that, and again during the drying also it should not catch fire. So many other things are there basically. So it is easy to cast and then dry it out. So one has to go for the additional drying and that's it. There is no specific process involved there. The only thing is that yes, how much it is entrapped is the more important. How it is entrapped. So whether you are casting with the things. So it's a normal process of optimal experimentation basically. Obviously, this is one part where it leads to inconsistency in the results sometimes. These are when you do research, definitely sometimes one experiment might give a more strength, less strength. So these are all the things one has to see that. So a continuous evaporation, whether all the solvent is evaporated, are there any trap is there or not? So these could be attributed in the experimentations, and the researcher has to be very careful while collecting the data. And if there is any erratic, then they must see such kind of experimental error or any kind of dryness problem. So optimizing the drying time is also important. At the same time, you cannot increase the temperature; it should not degrade the polymer, and many other consequences. One has to see that.
Okay, thank you.
Okay, any other questions from other participants? Okay, Mercy, you can read it.
Sir, shall I read the questions from YouTube Live and
yes, please.
Facebook?
Yeah.
There is a question from Mr. Radhashyam Samantha. Mainly, what type of polymer are used to formulate nanotechnological dosage form?
Is for the master batch? I don't know. Basically, what is the question again?
Mainly, what type of polymer are used to formulate nanotechnological dosage form?
I think maybe I don't get the question. If the question is right, I'll tell you. For example, if somebody is looking for let's say tire applications, and SBR or natural rubber is the right choice for that particular. Compatible polymer should be selected for carrying the nanomaterial into that actually. Now there are different, for example, in rubber, I can say that master batch with natural rubber is available, SBR is available, fluoroprene rubber is available, EPDM is available. So depending upon the need of that polymer, and this is being used. So the materials are specially selective for the application oriented, because that polymer can take when you are using, you are trying to mix with the other polymer. The polymer compatibility should be there, so that if that is compatible, the materials will get into the matrix. That is what I hope it answers. Otherwise, they can chat with me separately. I don't. It's because the question was little tricky. So if my understanding is correct, this will answer. Otherwise, they can always be in touch with me.
Thank you, sir. The next question is from Mr. Partha Halder. He's asking, what happens when silicon polymer composites with CNT in different ratio? What happens when silicon polymer composites with CNT in different ratio?
Yeah, with the dose it increases the basically mechanical strength improves, and the tear resistance improves, because the silicon rubber as such mechanical strength are very weak as such basically. It's not very high temperature, but it has got high temperature resistance, low temperature resistance in terms of compared to other rubbers. But when we add CNTs, of course, it can even increase the temperature resistance, and mechanical strength will be more, which comparatively lower normally compared to other rubber basically. So the strength will improve, and heat resistance, it will further improve basically. So these are the advantages one can get out of that actually.
Oh, thank you, sir. One question from Venkateshan. He's our student. He asked the question: while recycling the process of tire, is there any environmental issue?
While processing the tire or reprocessing the tire?
Recycling.
Yes. Of course, the tires are being recycled in different ways. For example, they make crumb powder, so powdering the things with the mechanical destruction, and then they make a powder. They sell in the market of different coarse sizes basically as a part of it. Then they use the chemicals and they recycle it, and that is also there. Another one is incinerate. They take into the very high temperature, they burn the calorie of this particular tire, and they take out oil, they take out carbon black, they take out the materials, metals, etc. And there, of course, pollutions are more actually compared to all other processes basically. So the crumb is not very much. That means the particle size, it doesn't much if it is done in a systematic closed loop. Whereas when they do a chemical process, controlled way, it is okay. But when they go for incinerations, there are lots of industries are banned in Maharashtra, Gujarat, and all. They were doing incineration method to prepare the oils, which has high calorific values, which was useful for substitute as LDOs. The only problem is they are having the dioxin and other carcinogenic materials. So the carbon black come out of such process, or the oil come out of such process, are not being regulated properly. So there has been lots of pollutions found. So the government of India, Maharashtra, and other pollution control board has banned that basically. But there are technology advancement has come with a controlled oxidation process. They are able to control, they said, but still that's not been validated and that's not been permitted as such basically. So these things processes are banned actually. Otherwise, with the normal process of reclamations, it's quite good. So there are industries are operating, and with the proper monitoring, it is okay. It creates some environmental pollutions, but still it is within the control basically. Yeah.
Okay, sir. Thank you, sir. And another one question was asked by Dr. Rishi Mahajans. It's a specific question. Benzotriazole, especially 2-mercaptobenzotriazole, abbreviated as 2-MPT, in a rubber industry's wastewater can be released in a large quantity, and it will be easily released into the environment, they can cause the health effect also. Are there any research are doing at your institute related with the water treatment of these toxic materials to remove or the RO system, something, sir?
That's a very good, wonderful question. That's really reckoning the things. I did not get into the depth of the discussion during my bioadditive based alternate materials, which when I was highlighting basically. There are materials like MBT, TMT, even zinc oxide is been largely used in the rubber industry, which are they are all looking for alternate materials. In fact, IRMRA is preparing a guideline document and BAS document for equivalent to REACH ROHs in abroad when they are being part of standards here. Actually, we are taking that. Actually, we are preparing a document for that. As such, specific to that question, MBT and in India it is not banned because we didn't find alternate suitable materials. Though there are many bio-based and other materials are being used there. But the only thing is that if it is of food applications, there is a restrictions. If it is non-food or industrial applications, they are not right now restricted. Whereas other countries like Europe and US and other areas are restricted. So that's why when rubber products are exported, they are supposed to comply with all these European REACH compliance and ROHS compliance. Even in India, we started working on it. When the materials are inside customs, we test and then certify basically. As a part of regulations, not much regulated, but is in the process. Government of India, Bureau of Indian Standard is part and parcel of such exercise already. So that is where the industry is looking forward an alternate, material development to replace. Not only such, there are a huge list of chemicals out there, like for example, DOP, zinc oxide, TMGD, all those things basically. So the equivalent materials are available. Those who are having concern if it is largely consumed. In ISO TC 45 also, we have been debating this year. Like I've been last 12 years, I have been attending this ISO meetings, and where there is a one specific committee is being formulated only to look after these environmental concerns of the rubber industry. So how these materials are during the run out tire when it's run out, it is going out and then it wash away with the water and then goes to the street. Sea and water gets contaminated and ground level gets contaminated. It's true. But the thing is that, yes, they have been telling that how to minimize the usage. Right now, we don't have an options, and so we are continuing with it. But very soon, industry will come with a guide. The ministry will come with the guidance, and maybe a restriction will be imposed in near future. Actually, we are into that research. There is no doubt about it, and we look forward to collaborative research for such things even more. Yeah.
Okay, sir. Thanks a lot, sir. And one more question, name not mentioned. What is the role of double layer hydroxide, LDH, as a nanofiller?
Well, see, when the double layer hydroxides are there, it facilitates more interaction basically. So what really happens basically, whenever there is a hydroxyl group, it facilitates ionic bonding, then the hydrogen bonding. So it could be a part of partial of when ionomers clusters. So what really happens? It facilitates such kind of interactive things basically. And also at a time it facilitates for flame retardancy basically. So it plays an excellent role in reducing the flame suppression basically, and that's the thing. So LDH is is being looked into. ATH, LDH, all these things nowadays they are looked into the environmental friendly and also flame retarding point of view, and with other normal reinforcement other things basically. So specific to the polymers, it facilitates interaction basically. And once it is inside through, so through the hydrogen bonding and ionic bonding, it gets fixed up basically. Morphology fixation will take place actually, compared to other things. That's how.
Okay, sir. Thank you, sir. Now I can give the opportunity to the participant, those who are in the Zoom link, you can unmute and directly talk with our director. So please use this opportunity. Participants, anybody can unmute and you can ask. Okay, if no question, then I can go with the YouTube link question. Mercy, please try to ask.
Hello.
Yes, sir. Yes, please.
Yes. Okay. So as our director sir, he has said or he has mentioned just now that there are so many chemicals those are used in tire compounding are banned in outside India, especially in Western countries. But in one slide, he has shown that we are basically most cases we are using tire. I mean, we are exporting tire to those countries. Since those chemicals they are banned in Western countries, but still we are using in India. But how they are, I mean, accepting those tires? Those are made
Absolutely. Excellent question. Excellent question. You got the point actually. Yeah. See, that's what the thing basically. When you are exporting to Europe or US, and basically the norms are very stringent over there. So the raw material selection and even those level of dosage, everything is been engineered to suit for their applications. So that means basically when India is able to export to the countries like Europe and US, to that extent they are capable of making the good products basically. But in India it is less regulated right now. We are looking forward basically because India cannot regulate without an Indian standard basically. So we are trying to bring it that standards actually. So for we are trying to only regulate the incoming materials. And also now domestic materials, domestic market also we are trying to do so actually. Because this is the awareness now actually. So what really happens basically when we regulate such things, basically one has to be very careful. The domestic industry should not die basically. So we look into a different angle actually. And basically the low cost material, low cost tires are imported again without restrictions that is being sold in the market. So we brought the safety as a part and parcel of the regulations now. India has mandated that all the tires made in India or abroad has to be tested for ISA marking as a safety part. Now is being sold in the market basically. Now the second stage is there is a tire labeling is planning to be basically wherein that energy saving fuel front low rolling resistance, wet grip, and the traction. So these sound and noise basically. So these are the parameters are being planned, and also the Bureau of Energy Efficiency, the PCRA, Petroleum Conservation Research Association, is also coming forward to rate the tires based on rolling resistance and wet grip and noise. They're going to rate the tires 5-star, 4-star, 3-star, just like your air conditioner is being rated power consumption basically. Here also the fuel consumption basis there is a norms are going to be there. The only problem is the testing infrastructure is not completely available in India. Some of the facilities are very costly. So IRMRA also is looking for the grant from the government, and we are into the making facilities for that. So government laboratories are supposed to be equipped. So 2-3 other laboratories are also getting equipped. So the regulations are getting stringent. Basically, they are coming to the next level. So the same thing, the Bureau of Indian Standard is looking for regulating chemicals and environmental other norms. And our ministry, our own ministry, DPIIT, Minister of Commerce Industry, and Minister of Heavy Industries, and also the Bureau of Energy Efficiency, they are looking forward regulating the tires for energy reduction, basically fuel consumption, all such things. Basically, there is a move is going on. It takes India is a huge country. It takes long time for bringing out any regulations. One has to see all the aspects because any regulations imposing should not put any stoppage in the production and consumption things basically. So we are looking into different angles. The government is already on the job. Maybe in a year's time or 2 years it will come basically. It's coming up basically. Yeah. But of course, those who are exporting, they are over cautious. So anything which goes out, they have to be very careful while making the things, because a huge rejection, if they go out of India and they get rejected, the huge penalty comes there actually. So whatever they make for abroad, they're making more cautious actually. So they may not use those chemicals which are banned in outside, and they may use with limited dosage so that it doesn't fail over there, or rather that's all.
Thank you.
Okay, sir. Thank you, sir. We have received few more questions from YouTube link. Mercy, please read it. Unmute your mic and read it, Mercy. Unmute your mic. Yes.
How to produce defect-free graphene oxide layer onto a porous support? It is a question from Dr. S. Kalai Selvan.
I'm sorry, I'm not expert in the making the graphene oxide. I must admit that because it's altogether a different technology. I know how to use it. I've been processing it in the polymers, how to use it, but I never been part of the production and manufacturing. It's totally a different techniques, basically. So I should not comment on that actually. So because yeah, it's a different techniques as such. We are once it is done, we process and then try to take the advantage of the industrial application. So we are into more application development than the things. I'm not expert in making that. I must admit
Yes, sir.
that.
We totally understand. No problem. So go for the next question.
Yeah.
Here is a question from Mrs. Sandhya Anand Kumar. She's asking, is the green chemistry followed during manufacturing the rubber? Is any research going on using plant extracts in manufacturing?
Yeah, here it's a natural product extraction. Basically, on the research level is happening. Basically, not in the commercial level. Basically, because the bioadditives and all, like we have been working on it. There are a couple of patents also filed, basically, and even other institutes also working on it. But as such, only limited number of ingredients have come in as a bioadditives inside the rubber industry as such, basically. But that's the future. In future, even in abroad also, everybody is doing research, but commercially is not much. In fact, for example, there are vegetable oils, bio-based oils have come as a replacement for aromatic oils, but still not in India. Low PC oil, low all those things. People are trying to explore other additives as such, basically, but not in India actually. Yeah.
No problem. Next question, Ms.
The next question is, sir, what is the role of double-layered hydroxide as a nanofiller? Actually, the name is.
This one we already asked. This
I
one
explained
we
that.
already asked.
Yeah, I explained that actually.
If no question, audience, please unmute your mic, and we are giving one more chance to you. You can directly talk with our director. Okay. So there is no question. On behalf of Department of Chemistry, it's my duty to thank our director, because for his kind acceptance and his valuable time he is spending with us. Thanks a lot, sir. Now the session is hand over with Mercy. Please, sir.
Now we are at the end of the day one session. We must always find time to stop and thank the people who make a difference in our lives. To deliver the vote of thanks, I request our senior professor, Dr. N. Hajra Bibi Ma'am, Department of Chemistry, to deliver the vote of thanks.
Respected chief guest of today's event, Dr. K.Rajkumar, Director, our beloved Dean, Dr. S. Kutirani, and HOD, Dr. D. Iswaramurthy, Coordinator, Dr. N. Vasimalai, my dear colleagues and my dear friends. Good evening to one and all present over here. I am Dr. N. Hajra Bibi, Professor, Department of Chemistry. It gives me an immense pleasure to propose vote of thanks on behalf of Department of Chemistry. Our Department of Chemistry launched a 14 days faculty development program voyage today on material science and nanotechnology. First, I would like to thank Almighty who gave an idea and helping us for the successful launching of this voyage. Next, I would like to express our sincere gratitude to our management, Pro Vice Chancellor, Registrar, who are the main driving force to direct us to do wonderful program. Next, I would like to thank Dr. K.Rajkumar, Director, Indian Rubber Manufacturers Research Association, Ministry of Commerce and Industry, Government of India from Maharashtra, who is the first man traveling in our ship. He immediately accepted our invitation in spite of his busy schedule. Thank you, sir. He delivered a lecture on advances in polymer technology and nanocomposites. He delivered elaborately a very informative lecture on various nanofillers and its properties and various methods of preparation of nanocomposites. He also told about the role of faculties to create employable human resource, as well as the research activities should fulfill the need of industries. Next, we would like to express our thanks to conveners Dean Dr. S.K. Rani and HOD Dr. D. Iswaramurthy, who are the persons launching the program in the correct direction. Now, I'd like to thank the coordinator, Dr. N. Vasimalai, who planned to launch and drive the ship for 14 days. I also thank the supporting team for successful launching of this program. Last but not least, I'd like to thank all participants who are traveling in the ship for next 14 days. The mission will be completed if you travel along with us. Support us all 14 days by listening. World is a laboratory, life is a test tube. Centrifuge your sorrows, residue will be happiness. Thank you once again. Thank you.
Thank you very much. Thank you, Dr. Vasimai and others, actually. So thank you very much for your wonderful platform. And I wish the program was very well successful for next 14 days. Actually. Thank you very much. Thank you.
Thanks a lot for your coming, sir.
Thank you.
And dear participants, please check the chatting box, those who are in YouTube also. So we have posted the feedback form. This feedback form, it is active for 30 minutes. Kindly fill and send to us. And the last column, we have given the specific comments. You can give your specific comments. The tomorrow session will be started at 4 p.m. Tomorrow's speaker, Dr. N. Sandhya Rani, Professor, National Institute of Technology, Kerala. So see you by tomorrow. Thanks a lot. Bye.
Thank you. Bye-bye. With your permission, I'll leave the session.
Sir.
Thank you.
Yes. Please.
Thank you. Thank you.
Thank you. Okay. Merci. Okay. Vengat, are you there?
Yes, sir.
Okay. Close the session.
Vasimalai.
Yes, sir. Yes, please, sir. Yes.
Tomorrow program starts by 3 o'clock only, not 4 o'clock.
No, sir. Time was changed, sir.
Okay. Then okay. No
yes,
problem.
Yes, sir. Thank you, sir.
So I request every participant to fill the feedback form without fail. Thank you.
In case of any problem to fill this form or some activations, please feel free to call us or just send a mail to us. Thanks. Thank you.
So can I close the session, sir?
Yes, please close it.
Okay, sir.
Venkat,
Yes, ma'am.
sir. In YouTube, the participants are asking for the feedback.
Yes, ma'am. I have posted, ma'am. I have posted. I have posted, ma'am.
Venkat, do it one more time. Do it one more time.
Sir, yes, sir. I am posting for every comment, sir. Yes.
Do it one more time. Yes.
Hello,
yes.
Dr. Panda speaking for IGIT Sarang, Odisha. Yes. Sir,
Yes,
actually,
please,
during submission, it is not submitted.
The form not submitted?
Submission, there is a problem. It is not responding. Submission form is not, submission bottom is not responding.
Okay, sir. We will solve it, sir. Please come through by phone call, sir. Thank you, sir.
Okay.
Please mail us, sir. Please mail us also. If you have any. Vasimali, sir, left, sir.
Okay, Venkat, to that person who was asked, you send a mail. Okay.
Yes.
Get the feedback. Okay.
Please mail us. I have given a mail ID also. So in YouTube also, I have posted several times the feedback link. So please.
Once again, you posted,
sir. 56 times I have posted, sir.
Some of them may not have seen it. Okay, today around 400, yeah?
The comments will keep on moving, ma'am. அது வந்து நம்ம மேல scroll பண்ணி பார்க்கணும். நீங்க scroll பண்ணி பாத்தீங்கன்னா என்னோட மெசேஜ் எவ்வளவு இருக்கு பாருங்க.
ஆக்சுவலா ஒரு 5 o'clock போல நான் பாக்கும்போது 163 பார்ட்டிசிபென்ட்ஸ் தான் இருந்தாங்க. இப்போ ஃபீட்பேக் முடிச்சிடுச்சுன்னு சொன்னா 240.
இப்போ நிறைய பேர் வந்து மியூட் இது பண்ண மாட்டாங்க, பார்க்காம வந்து கடைசி நேரத்தில் வந்துப்பாங்க. ரைட்டா?
இப்போ 240, இப்போ வந்து நம்பர் வந்து 240.
Keep on posting, but even though I'm posting, they're asking, give me feedback link, please. Feedback link, please.
That is a trend, Indian trend, pa. Leave it. They can't understand, pa. That's the problem. Okay, totally how many? 340. Venkat?
Yes, sir.
Total number of participants in YouTube and this one together, 340.
Together, I think yes, sir, 340 or something.
Okay, it's good only.
Hello.
Yes.
I am Dr. Suchita from Delhi. Actually, I submitted my feedback and it's submitted. Is this feedback response mailed? Can we get mail of this also or not?
No,
You
for
want the mail of the response?
Is it come or not? I don't know.
No, it will not come. Actually, from tomorrow it will come. Sorry for the inconvenience.
Okay, fine. And one thing more, it's the time change for only tomorrow's session.
Yes, ma'am.
Also
Yes, ma'am.
further
Yes,
more.
ma'am.
No, please refer the this thing brochure.
It's at
No,
3.
ma'am. No, ma'am. Tomorrow only we get changed. Anyhow, we will inform you. Okay, ma'am.
Yes.
In all
Hello,
ways, we
sir.
will remind
Hello.
you. And what will be the next session? That we will remind you.
Okay.
Hello,
Okay,
sir.
thank you, ma'am.
We have not received.
sir.
I have not received the feedback form.
Are you attending through Zoom or attending through YouTube?
YouTube, sir. YouTube.
Okay. We
YouTube.
will,
Okay. I have posted it several times. It would be there. Again, I'll post it. No problem.
Sir, please send it on
No,
the.
sir, actually, it is not visible, sir, because I was attending in Zoom, but means simultaneously because of network connection, I was means I have opened
At
YouTube.
least on the WhatsApp group, sir. Or at least on the WhatsApp group.
Venkat?
Yes, sir.
Do one thing. You send the feedback link to the WhatsApp group.
Okay, sir. I'll do it.
Because of the network problem.
Okay. I will do it. That's not a problem, sir. I'll do it.
And those who attended only give the feedback.
Sir, please send it on the WhatsApp group, sir.
Hello.
Yes.
Sir, purila, sir.
No, she is telling you have to send through WhatsApp group.
அதுதான் சார், அதுதான் பார்த்துட்டு இருக்கேன். நான் பண்ணிட்டேன், திருப்பியும் வரல சொல்லிட்டு இருக்காங்க. அதுதான் பார்த்துட்டு.
You asked her to send the email ID. To that mail ID you can send it now.
Okay, sir. I am just posting it right now.
Those who are not getting the feedback link, you send your mail ID in the chat box.
Hello, sir.
Yes.
சார் மருது பேசுறேன் சார். யூடியூப்ல நாங்க லிங்க் சென்ட் பண்றோம் சார், சென்ட் ஆக மாட்டேங்குது சார்.
அதான்ப்பா நீ என்ன பண்ணு?
I have posted it.
Madam, please send it on the WhatsApp group, madam.
Okay, ma'am, you do one thing.
Yes, சொல்லுங்க.
Mail ID, ma'am.
Yes.
You send the
லிங்க்ங்களா? அதோ வந்துருச்சு. நான் போட்டுட்டேன். Yes. இல்ல சார், போட்டாச்சு. அண்ணா மருது அண்ணா போட்டாச்சு.
வந்துருச்சுப்பா. இப்பதான் வருது. நாங்க யாரும் போஸ்ட் பண்ண முடியல, நீ மட்டும் தான் போஸ்ட் பண்ண முடியுது.
அவன் போஸ்ட்னா மட்டும் தான் பண்ண முடியும், மத்தவங்க பண்ண முடியாதுலப்பா.
ஆமா சார், எங்களுக்கு தெரியல சார் இது.
இல்ல போஸ்ட் மட்டும் தான் பண்ண முடியும், நீ நானும் பண்ண முடியாது. ரைட்டா?
ஓகே சார். இல்ல சார், யூடியூப்ல சார்.
அதான் யூடியூப்ல தான்ப்பா. யூடியூப் நல்லா இருக்கா? நம்ம டிபார்ட்மெண்ட் யூடியூப் நல்லா இருக்கா?
நல்லா இருக்கு சார், சூப்பரா இருக்கு சார். லைவ் எல்லாம்
இன்னும் நிறைய இதை போடணும். கலக்கலாம் உங்க கையில தான் இருக்குது. ரைட்டா?
ஓகே சார்.
நாங்க லான்ச் தான் பண்ணிருக்கோம், அது ப்ராபகேட் பண்ணி பெருசா கொண்டு வரது உங்க கையில தான் இருக்குது.
ஓகே சார், தேங்க் யூ சார்.
ஒவ்வொரு பேப்பர் அக்செப்ட் ஆனது எல்லாமே அதுல போட போறேன் நான். ரைட்டா?
சரிங்க சார்.
ஃபர்ஸ்ட் பேஜ் மட்டும். உன் பேப்பர் எந்த நிலையில இருக்குது? ஹலோ.
Yes, sir.
மருது பாண்டி.
ஹலோ. சொல்லுங்கண்ணா. இல்ல நான் போட்ட கமெண்ட்ஸ்ல போட்டுட்டேனா வந்திருக்கும் இப்போ. ஆமா.
வரல யாருக்குமே தெரியல அந்த கம்ப்ளைண்ட் நாலு பேர் அஞ்சு பேர் எனக்கு ஃபோன் பண்றாங்க. என்ன பண்ணு அந்த டிஸ்கிரிப்ஷன் வரும் தெரியுமா யூடியூப் ஏதாவது ஒரு யூடியூப் புதுசா போடுறேன்னா அது கீழே டிஸ்கிரிப்ஷன் சொல்லி ஒன்று வரும்.
ஓகே.
எடிட் பண்றப்போ உள்ள போய் பாரு. நீ இப்ப உங்ககிட்ட இந்த யூடியூப் பாஸ்வேர்டு இருக்குல்ல?
இருக்கு.
அது உள்ளார போய் வீடியோ ஏதாவது போஸ்ட் பண்றேன்னா அது கீழே டிஸ்கிரிப்ஷன் சொல்லிட்டு ஒன்று வரும்.
ஓகே.
அதை கிளிக் பண்ணி இப்போ போட்டிருக்கிறதுலாம் வந்திருக்கு. நீ போட்டிருக்கிறல்ல கரெக்டா போட்டிருக்கிறல்ல சேட் பாக்ஸ்ல வந்திருக்கு. இப்போ வந்திருக்கு.
ஓகே.
இருந்தாலும் நீ என்ன பண்ணி கீழே போட்டு ஆக்டிவ் ஃபார் ஒன்லி 30 minutes போட்டு வித்தின் பிராக்கெட்ல
போட்டுட்டேன்.
ஓகே.
Any other problem, participants?
No, madam. Thank you.
Okay. Ishwar Modi sir, can I close the session or what, sir? Ishwar Modi sir?
Excuse me, madam.
Yes.
During the session, there was frequent disruption in the voice, audio.
வெங்கட்.
Yes, sir.
இதுவும் லைவா போயிட்டு இருக்கு. ஜஸ்ட் க்ளோஸ் இட். அட்மின் வெளியில வா. நீங்க பேசுறது வைக்கிறது எல்லாமே லைவா போயிட்டு இருக்கு.
ஓகே.
எஸ் ப்ளீஸ் க்ளோஸ் இட். எல்லாமே யூடியூப்ல லைவா போயிட்டு இருக்கு.